Hi, I'm Nilima. I'm a software engineer at Snowflake, and I work on adding native support for Iceberg tables in Snowflake.
Hi, I'm Ganeshan. I'm also a software engineer at Snowflake and I work on data loading into Iceberg tables.
Ganeshan and I are going to talk about onboarding your data lake to Iceberg tables. We will discuss why Iceberg is a good choice of table format for your data lake, how to migrate your existing datasets to Iceberg, and cost effective ways of loading new data into Iceberg tables. The simplest way to describe Iceberg is as an open table format for tables with SQL behavior. It was designed with interoperability in mind and has a rich ecosystem of tools. Because of this, when you standardize on Iceberg as your table format, you get the most flexibility for choosing your data processing tools. Guarantees for foundational database concepts like transactional consistency and ACID compliance were hard to come by in the Hive and Hadoop ecosystem. Whereas in the Iceberg table format, these were built right into the table format and available from the get go. You also get data lake specific features like hidden partitioning that will help you align your existing datasets to Iceberg tables. These alone are great reasons to standardize on Iceberg as the table format for your data lake. By combining Iceberg tables and Snowflake, you can bring the power of Snowflake to your open data lake. Snowflake enables advanced data warehousing features like dynamic tables, materialized views, search indexes on Iceberg tables. Using Snowflake, you can replicate your Iceberg tables cross region and cross cloud and also share them on the marketplace. Iceberg tables in Snowflake support all data governance capabilities like row access policies, masking policies, tag based masking, and so on. So, all of this sounds great, but what if you don't have Iceberg tables? We have a couple of options. The first option is to migrate the data in place. This is a simple metadata translation from a source format like Hive or Delta to Iceberg. It requires that the data files are in a format supported by Iceberg like Parquet because migrating the table does not rewrite any of the data files. It is a fast and a cost effective way to create an Iceberg table. The second option is to simply insert data into an Iceberg table. This can be run on any dataset on which you run a select query. It is used when your existing dataset needs to go through some meaningful transformations. This method will create new data files and with consistent column types and schemas and collect all the relevant stats in the Iceberg metadata. Let's take a look at how in-place migration works. The source table is typically defined as a bunch of data files with some metadata like the table schema, partitioning information, table properties, table versioning, and so on. In-place migration is simply a translation of the table metadata to Iceberg metadata. The Iceberg metadata that is created points to the same data files as the source table. You can hang on to the source table definition for a while in case you need to roll back. Once you are confident about with your testing on the Iceberg table, you can drop the source table metadata. This migration process allows creating an Iceberg table from existing datasets in a transactionally safe way. Let's walk through a couple of use cases. Hive tables have been around for a while and are commonly used in data lakes. If your existing dataset is in Hive, the Iceberg SDK has a simple Spark procedure to migrate your Hive table to an Iceberg table. The first step is to create a snapshot of the table without replacing the original table. The snapshot table can be used for almost all read write operations. This allows you to test your Iceberg table with no downtime to your production table. This testing is, of course, optional. In the second step, you actually migrate your existing Hive table to Iceberg by calling the migrate procedure. This replaces the original Hive table with an Iceberg table and uses the Hive metastore as the Iceberg catalog. Another popular use case is Parquet directories used as tables. To convert these to Iceberg tables, you first need to create an Iceberg table with a schema that matches the schema of your Parquet files. The Iceberg SDK has a procedure called add files, which will then list all the files under the specified path, scan their Parquet footers, and convert it to stats in the Iceberg metadata. You can use the metadata files created by add files and register the table in an Iceberg REST catalog like Polaris or even in the Glue Iceberg catalog. We now have an iceberg table that can be used with Snowflake, Spark, Trino, and many other tools. To use an iceberg table in Snowflake, you need to set up two things: an external volume that will provide access to the storage layer, and a catalog integration that will provide access to your iceberg catalog. Once you have these, you can create an iceberg table in Snowflake and use Snowflake features on your iceberg data. You can also convert it to a managed table, which enables writes using Snowflake. Once a table is managed, you can use cost effective ways to load new data into the table. With that, I'd like to hand over to Ganeshan to talk about loading data into iceberg tables.
Thanks, Nilema. We've learned so far that it is easy to create an iceberg table from existing datasets or from a variety of existing table sources. Next, we'll look at the different ways to load data into an existing iceberg table in Snowflake. I'll be discussing the three primary methods for loading data into Apache Iceberg tables in Snowflake, which align closely with the approaches used for non iceberg tables. First, we have the copy command. This is one of the most popular ways to load data into Snowflake. It is particularly effective for bulk loading large volumes of files. When using the copy command, you can customize the sizing of the virtual warehouse. This allows for deterministic costs and latency, enabling you to achieve good cost efficiency when the warehouse is fully utilized. Next, we have Snowpipe. This is a continuous ingestion service for files that also utilizes the copy command under the hood. So it supports all the copy options. What sets Snowpipe apart is its event driven nature. It monitors cloud storage event notifications for newly created files and kicks off the ingestion process immediately. This means you don't need a dedicated virtual warehouse, making it a serverless service. In most cases, Snowpipe offers a remarkable time to query of less than 30 seconds. Last, we have Snowpipe streaming, which provides low latency ingestion. This method requires a client SDK to insert rows, allowing for real time data flow into your tables. It is designed for high throughput while maintaining low costs, making it an excellent choice for applications that require quick access to newly ingested data. In summary, whether you're using the copy command for bulk loading, leveraging the convenience of Snowpipe for continuous ingestion, or opting for Snowpipe streaming for low latency needs, Snowflake provides several options to efficiently manage your data loading in Apache Iceberg tables. Next, let's look at the copy command in a bit more detail and learn more about how it can be used to load data into Apache Iceberg tables in Snowflake. A new copy option, load mode, is being introduced to support efficient data loading into Apache Iceberg tables. The default behavior of this new copy option is to rewrite the source data into the target tables format, depending on whether it's Iceberg or non Iceberg tables. In the case of Iceberg, the target file format is going to be Parquet. The syntax for this is copy into your Iceberg table from your stage. A stage is an object that you create in Snowflake to point to a cloud storage provider location that has your data files. Copy command also supports projections and transformations, which allow you to change the source data before it is loaded into the Iceberg table. Source files can be in any of the file formats supported by copy. A few of them are shown on your screen: CSV, XML, and JSON. When loading data into Iceberg tables, the target files will be Iceberg compatible Parquet files that are created in your external volume that is attached to the table. A simplified version of the query plan for copy is shown on your screen. Let me walk you through it. The query plan consists of three main steps. The first step is to scan the rows from the source file using scanners that are specific to the file format. After the rows are scanned, the data is transformed in the next step. In this step, any projections or expressions are applied, and the resulting data now matches the format of the target Iceberg table. In the final step, Parquet files are created in the external volume of the table, and in the commit operation, Iceberg metadata is generated. This option can also be used when the source files are already Parquet, especially if you want to transform data before loading. In some cases, though, such as when the source files are very small, it's also better to let Snowflake rewrite the source Parquet files and create optimally sized output files that will result in better query performance. For Iceberg tables, Snowflake has two other flavors for copy that has different values for the copy option load mode. These options can be used when the source data files are Parquet and you want to avoid an expensive scan and rewrite of the Parquet files. The first one is the one with the value add files copy. The syntax for this is copy into your Iceberg table from your stage with load mode equals add files copy. This option does not support transforming data before it is loaded into the Iceberg table. You should use this option when the source Parquet files are not under the table's base location, but instead are in another location. It could be in the same region, cross region, or even cross cloud. It's also ideal if the source files are following the sizing recommendations for optimal query performance. Let's look at the simplified query plan when you use this option. Copy will no longer scan rows like it did in the previous option, but instead copy the file from the source location to the table's base location, and then commit the file to the table, resulting in the creation of Iceberg metadata. Because we no longer scan each row from the source file, this option is both cheaper and faster than the full ingest mode. The final way to use copy to load data into Iceberg tables is using the load mode with the value add files reference. The syntax for this is copy into your Iceberg table from your stage with load mode equals add files reference. This option is similar to the add files copy and also does not support transforming data before it is loaded into the Iceberg table. You should use this option when the source Parquet files are already under the table's base location and can be used as is. It is also ideal if the source files are following the sizing recommendations for optimal query performance. Let's look at a simplified query plan for this option. Copy will no longer scan rows, but since the Parquet files are already in the table's base location, we no longer need to even copy the file and can simply commit the file to the table, resulting in the creation of Iceberg metadata. This is the fastest and the cheapest way to load data because there is minimal work needed to be done to load data into the table. This way of using the copy command is similar to the Spark add files procedure that allows you to use existing files in place and add them to an Iceberg table. Understanding the different copy load scenarios will help you optimize your data loading strategy in Snowflake. So let's take a look at how you can decide which strategy is best for loading data into Iceberg tables at Snowflake. The first question you must answer is whether the source data is in Parquet format. If the answer to this question is no, that is, the source data is in CSV, JSON, or some other copy supported format, then the only option to load data is using the full ingest mode, using the syntax that is shown on the screen. If the source data is in Parquet format, then we have a few options depending on how we want to load the data into the table. The next question is whether we want to transform the data in any way before we load it into the table. If yes, then we fall back to the full ingest mode because we will need to rewrite the source data into new Parquet files. If we don't want to transform the data and can directly add the files to the table, then the final question that we need to ask is where are the source files located? If the source files are under the table base path, then we can use the add files reference mode that we talked about a few minutes ago and simply add the files without any additional work. If the source files are not under the table space path, then we can use the add files copy option, and this will copy the files to the table based location before adding it to the Iceberg table. Next, let's look at the performance of these copy load options. The columns show the three values for the load mode copy option that we discussed and their different properties, starting with the source file format. Full ingest supports all copy file formats that are shown on the screen, whereas the more efficient copy options are only available when the source data is in Parquet file format. Full ingest also supports all copy transformations, whereas the other two do not support any transformations of the source data during loading. In terms of performance, both latency and cost, the add files reference option is the fastest and the cheapest option, followed by the add files copy option. which is to make a copy of the file under the table base location. The full ingest mode has to scan all the rows of the source file and create new target files. So it is slower and more expensive than the other two options. But full ingest can perform full validation of the source data and either skip bad rows or abort the command if bad data is detected during load. This is not the case with the other two options, where Snowflake only does minimal validations of the Parquet footer and data type checking, but does not ensure that all the rows can be read successfully. Finally, let's take a quick look and recap Snowpipe and Snowpipe streaming options. Snowpipe is used to continuously ingest small or large volumes of data arriving continuously. It is event driven, serverless, and highly scalable way to load data into Iceberg tables. Snowpipe uses copy underneath, so it will support the new load mode copy options for Iceberg tables and enable cheaper and faster data loading. Snowpipe streaming supports streaming rows into Iceberg tables just like it does today for non Iceberg tables. For Iceberg tables, Snowpipe streaming will create Parquet files in the external volume attached to the target table. Snowpipe streaming also supports ordered ingestion of rows using the concept of channels on a table. This brings us to the end of the presentation. To recap, here are the key takeaways. Snowflake's support for Apache Iceberg ensures easy and efficient integration with existing data lakes. We learned today that it is easy to create an Iceberg table from existing datasets or from a variety of existing table sources. Snowflake offers cost effective and scalable solutions for loading data into Iceberg tables. Whether using bulk ingestion or streaming data, Snowflake optimizes resources and supports automatic scaling, helping you manage large data sets quickly and without unnecessary costs. By utilizing Snowflake's powerful query engine and unique features like data governance, dynamic tables, replication, and many more, you can supercharge your Iceberg tables for advanced analytics. This combination empowers you to unlock faster queries, better data governance, and enhanced operational efficiency. On the right side of the screen, you can find some other related sessions that will help you learn more about using Apache Iceberg with Snowflake.
Thanks for watching.